The analog astronauts, they are testing also the physical demands. So what you see here is the AUDA suit. It's a spacesuit simulator, so you can't use it on Mars, but it's designed to simulate certain aspects that astronauts will experience on Mars. So this suit has 45 kilograms. You can see what kind of tasks the astronauts have to perform. So they have to bend down, they have to walk for longer distances, and this can be very exhausting in the suit, in the heat. We want to have a tailored computer simulation of activities that the astronauts are performing during the mission. So we can beforehand simulate how exhausting, how fatiguing these activities are. We will tell the analog astronauts to perform standardized activities and then compare the measurements there with what we simulated and to see how good our simulations can give a forecast for this situation. My background is I did a master's in sports science. What is very interesting for me is to track the movement of the astronauts. It's called motion capture, and we try to develop a system where we can capture the movements of the astronauts beneath the suit with small sensors. And other one would be muscle activity. We are placing sensors on the bulge of the muscle, and we are capturing the bioelectrical signal that is coming from the brain to activate the muscle. The signal looks very different on a fatigued muscle than on a non-fatigued muscle. And that's when an astronaut has to hammer something, or when he has to screw drive, get rock samples from the floor. So always when there are more repetitions, we can look at the fatigue over the repetitions. To my knowledge, there are no studies who are doing that in a field environment, and there's nothing that gets more field than an analog mission. So the Austrian Space Forum is doing a very good task to keep it high fidelity, and that is very important to show that it's working in a real working environment and not only in the lab or on the computer.